and we will present it and upload it to our YouTube site, which I've already put into the chat box. During this discussion, Matt McLean, who is also one of the admins here at Kane High Performance Computing, will be able to answer any questions and stuff and kind of watch the chat box and the question and answers area. So if you have anything, feel free at any time to put it into the chat box or to send in an actual question, and we'll make sure that gets covered for anything specific you may be interested in. Again, this is a two-parter. This first part here is going to cover the true basics. You won't, what you learn here will definitely be helpful for the second part. You do not need to stick around for the second part next week, but what you learn next week will hopefully make a lot of the work you're doing much easier, going forward with things that are in use for you. So I put the link in the chat box for where you can find our old archives and stuff. You can also, on the Getting Started section of our website, which is cac.engine.umh.edu, you'll find the webinar series, where you will find archive videos of all the old archive videos we have done in the past. And they will keep getting posted there as we expand the series. There's also a lot of other good video tutorials, specifically on our YouTube, which is what I had, put in before, how to transfer files using specific examples and stuff like that that aren't in the webinar format. So, what is the goal of what we're trying to accomplish today? What we're trying to accomplish is we want to be able to effectively, from using text-based commands in the terminal, navigate the high-performance computing system or any Linux or other type of Mac system we may have. The command line is very different. There's no mouse, there's no pointing and clicking and buttons that do things. But it is also extremely powerful in that you will find that after you've mastered it, you can do things faster in a more precise way than using a mouse, and also reproducible. I will show you how you can use the commands that we learned here today and combine them into a script. So if you are doing something regularly, you can actually not have to type out 5 commands over and over. You can just use the run the script that you wrote once. So first thing I want to demonstrate is how to actually SSH into a machine. SSH is called Secure Shell, and we have a bunch of information on our website how to do it specifically for our system. When connecting to the cluster, you SSH to the login nodes, but SSH, you can do it to pretty much anything. It stands for Secure Shell, so it's an encrypted connection for you connecting between 2 different machines. So here, let me actually just do it. I gotta share the right screen. Okay, everybody sees the terminal? So this is the terminal, this is the command line. So here I'm on a Mac and I'm running a command called terminal.app, and it opens up this terminal. Right now I'm on my personal Mac laptop, but the commands I use here are going to be identical to the ones that I use on a Linux machine, because Linux and OS X are both derived from a history of a system called Unix. So if someone says Unix or OS X command line or Linux command line, the commands you learn on one apply to the other. So it's handy that there's interoperability between them. SSH, if you're coming from Windows, you're going to need to use a different tool. You're going to need to actually install an SSH client, which is probably going to be point and click based. But once you're logged in, it will look like this. So from my Mac here, if I want to connect to a different machine, I would use the command SSH, and then I would give it the machine I want to connect to. So in this case, I'm going to connect to fluxlogin.engine.umh.edu. So this is the command, SSH. This is an option to that command, which is the host I want to log into. And then I want to give it an optional argument. In this case, I'm using mine as L. And this is my username. This is, you'll notice the username on my Mac is already Brock P. So if I omitted this, it would log in as Brock P. But that's not always the case. So this is how you specify what username. Let's hit enter. In this case, it asks for an M token. This is a little keychain dongle you've probably seen before. If you use our cluster, you definitely have already had one of these. But what it does is it prints out a number. It's a way that if someone guesses your password or steals your password, they can't actually log in because they don't have this special keychain. So right now I'm typing in 8 numbers. Notice it didn't print out anything on the screen. Same thing here. Now this is my password. This is the same password I used to log into Wolverine Access. You'll notice here again, it did not print out anything when I typed. No stars, no letters, nothing. Again, that's a security thing. It's by default. They won't know. If someone looking over your shoulder won't know how many characters are in your password. So you'll notice here that my prompt changed. It now says Brock P at Flux Login 1. So I am now at the command line of the remote machine. Now this doesn't have to be Flux Login. There's also login.itd.umich.edu, which is the generic login pool for the entire university. You know, this is how you connect to Exceed resources or just connect into, you know, your Linux machine running at home. So SSH is how you remotely connect to another machine. Any command I run here is now being ran on this Linux machine. Flux Login is a Linux machine. And so from here on out, everything I run is going to be ran on this machine. So if I'm consuming CPU, it's on Flux Login, which is a machine locked in a room that's a lot bigger than my laptop, not on my laptop, even though it's in this window that's on my laptop. You can SSH into a machine multiple times. So if you want to have something running in one and copy files in another, you can just keep opening terminals and SSHing in multiple times. So now that I'm on the machine, let's actually talk about the meat of what we're doing here today. So let me start up something. Okay, everyone should be seeing just a blank white screen now. This is just something where I'm going to illustrate some commands. Okay, so most of what we're going to spend any time is navigating the file system. This is how files and stuff are organized on the system. On Unix heritage machines, that is Linux and Mac machines, everything starts from something called slash. And this is a hierarchy. So you'll see something like slash mount slash something. So basically what you end up with is it's a hierarchy. So everything starts in slash, and then you make multiple folders. So what you end up with is you have slash, and then you have a folder underneath it, which would be like mount, which would then, you know, be slash, you know, one or more folders. So this is one folder under slash. There may be another folder called user, which, you know, will have, you know, folder bin. These are also called directories, etc. So it's this hierarchy. So what you end up with is you end up with a final thing that's, you know, slash mount slash SDB. You know, so say there's one called SDB. So these are all folders, and then there may be a file in here, you know, file.txt. So it's just a hierarchy. So these are directories. And then they can have files inside of them. So you can have multiple directories. And I'll actually get on a system and demonstrate this. But just be aware that everything starts from slash and then goes from there. I'll teach you the difference between relative and absolute paths, which will save you some typing. It's a shortcut, but it will save you a bunch of typing when navigating around. Because if I'm already in SDB, I don't want to type a command, you know, slash mount slash SDB slash file. What if I can just type, you know, ls file.txt, and ls is a command I'll show later. So I'll actually jump on a machine now and actually show you what this looks like, but I want you to be aware of this hierarchy. Okay, so keeping that file system layout in mind, there's a couple of basic commands for actually navigating them. So probably actually the most basic command is something called ls. This is short for list. This lists everything in the directory you're currently in. So in the folder I'm currently in, show me all the files in there. So if I run it, you'll see all these printed out. I have color turned on, so something that's black is just a file, something that's blue is a folder. So if ls lists everything, how can I get more details? If I want to list a single, so if I run ls, it prints out everything. What if I want to get details just on this file, xrandfiles.c? So what I can do is I can type ls and actually type out that file name. And so then it lists only that one. I can list multiple files and only list them, but that's not that useful. Normally what I want to know is I want to know how big this file is or something like that. For that, I'll use ls-l, that file name. And so here it shows the permissions, who owns it, what group owns it, and how big it is. So in this case, it's 5,000 bytes. So this is a relatively small file. It was actually last modified on February 21st. As I go through these commands, a lot of them you will notice will be in the form of command dash some letter. In the last case it was -l, which shows additional details. Dash some option basically means enables some option for. So ls by default lists the files. ls-l includes the details. So if I do ls-l without listing a specific file, it'll list all the files, but it includes all the details. So this is the same list as if I run ls, but includes all the details. So what are some useful options to ls? ls has a lot of options, but some of the ones you may be interested in would be, -l. Another one is t. T means sort the files by their modified time. So if I run this, you'll see that the oldest files on here were created August 15th, 2009, and gradually get newer. Or maybe not so gradually, but they do get newer. So another option then is to add on -r, which means, okay, sort them in reverse. So the -t says sort them by their last modified time. R means sort them in reverse. So when I ran it just lt, it showed the oldest file last. If I run it with R, it's the most recent file, which is this .map file that I created on the 23rd at 1:19 p.m. So some things about the logistics of options. You'll notice I did ls-lrt. That does the same thing as ls-l-r-t, which is the same thing as ls-t-r-l, which is the same thing as ls-l-r-t. You can lump the dashes together, or you can combine them any way you want, and the order doesn't matter. Sometimes order will matter, but in this case order doesn't matter because the options don't interact with each other. So ls lists the files in the folder I'm currently in. How do I know which folder I'm currently in or which directory I'm in? For that, I use the command pwd. This means print working directory. So you'll notice that, remember how everything starts at /? I am in the folder home under / in the folder brocp. So when I typed ls and I listed all those files, those were all the files inside this folder. So if I switch to another folder, like VASP, which I'll show you how to do more in details here, type pwd, now I'm in this folder, home, brocp, VASP. And so if I run ls now, the files here are different, because it's showing the files inside this folder. Feel free to ask questions as we go along to stop me if something's not clear or something like that. Okay, so pwd shows where I currently am. ls shows the files. How do I switch between directories? For that I use the cd command. So cd is the change directory. So if I wanted to change to /, I do cd/. I type pwd, I'm now in slash, so I'm at the top of the file system. If I type ls, I see all the folders under the top of the file system. If I cd to slash home slash brocp, now I'm back inside my home directory. So this can get a little tedious after a while, because what if I want to go to slash scratch support flux brocp temp mpb? I wouldn't want to type that every time. So what can I do to get around quicker? There's a couple of shortcuts, and these are handy things to know. If I want to refer to up a directory, so right now I'm in scratch support flux brocp temp mpb. What if I wanted to get to just here? Well, I could type out scratch support flux brocp temp, and that would put me in the right place, but that's a lot to type out. So how about I type cd ... Dot is a special command that means the directory above me. And you can actually have some fun with this. There's also another special one called dot. Dot means where I currently am. So if I do cd dot, it's valid, but I'm right where I was. You may run into this sometimes if you're trying to refer to a specific command and it says command not found. What you can do is you can do dot slash my executable. If you've ever seen somebody do that before, that's why they're referring to this directory explicitly and then the file inside of it. So I can combine these and do some strange things. So I'm currently inside brocp temp. I can get crazy. I can do cd ... which would put me into this folder. But then I can do temp, which puts me back to where I am. I can do ... which would put me back up 2. So I went up 1, back into it, then up 2. This doesn't have any true useful purpose, but it does work. And see, it puts me back into scratch support flux. So I can combine these together. So if I just want to move up 2 directories, I can do cd ... slash ... and that moved me back up to slash. Moving down, referring to specific directories, I can do cd / scratch support flux. If I want to move into brocp temp mpb again, I could do the whole scratch support flux brocp temp mpb. I can type that whole thing out, but instead what I can do is, since I'm already in scratch support flux, I can do cd brocp temp mpb, and that works. Why did that work? Notice there's no slash here. Because there's no slash, it does not mean start from the very top of the file system. It means refer to the directory I'm currently in. That was the same thing as if I move back to that directory, as doing cd ... brocp temp mpb. Because remember, the dot refers to the directory I'm currently in. And so this is what we call relative pathing. You don't have to type out the full path every time. You can just refer to the one you're currently in by omitting the slash. So cd mpb puts me into that location. So that's cd. That's what lets you navigate around the directory structure. Now, I'm going to show you another trick that I use probably literally thousands of times a day. That is the tab key. The tab key does something special. You're probably wondering how I typed scratch so fast there. The reason I was able to was because I typed cd / scr and then I pressed the tab key. The tab key completes the path. So inside scratch, or inside slash, if I look, here's the directories that are in there. The only thing that starts with the letters scr is scratch. So when I type cd scr and hit tab, the system looks inside slash and sees these are the folders. Okay, what ones of them start with scr? This is the only one. So then it goes inside of it. So then I can go inside of it. Inside scratch, it has all of these. So now watch this. If I type cd and I type sup, I hit tab, it stops as far as it can go. It puts out support flux. But if I hit tab twice in a row, notice it prints out two things. Notice there's two things that started with sup. There's support flux and support flux m. So it went as far as it could. It filled in the support flux and then stopped. At this point, I can just hit the final letter I need, press tab, and I'm done. Tab completion is extremely handy for saving you tons of time. Instead of typing out full folder names, type the first couple of letters, press tab, and it finishes out for you. It also works for other things. So module load MATLAB. If I want to run MATLAB, M-A-T, press tab twice. Hey, look at this, MATLAB. Type L, press tab. Now it completes it, MATLAB. And I run this and it starts up MATLAB. So it applies to binaries, file names, and directories. Tab completion, like I said, my muscle memory now is that I only type the first couple of letters of any folder I want and press tab. Tab, 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 tab. It'll save you so much time. First couple of letters, press tab. Even if it can't complete the whole thing, it'll complete as far as it can. Press tab twice and see the limited list of everything that matches what you were asking for. Okay, so how do I create these folders then? So if I go to a folder I'm working in, and I wanted to make a folder tutorial, I would use the mkdir command. So this is the make directory. So what that just did is it created the directory tutorial. And so now I can cd into that directory. ls, it's empty because it's brand new, it's got nothing in it. But that's how you make a directory. So as you want to make directories or folders or whatever you want to call them, and you want to create them to then put files into them, you use the mkdir, make directory, to move inside of them, to create them, and then you can use cd to move inside of them. So after you've created the directory, you want to delete some files, or you want to delete that directory. So I'm going to create some files here. So I've got 3 empty files because they have no size. A, B, and C. If I want to delete them, I use the rm command or the remove command. Unix, Linux command line systems do not have a trash or anything like that, so be very careful with rm. When you remove something, it is gone forever. So, be very careful. So rm A deleted the file A. RMB, gone. If I create A, B, and C again, I can do rm A space B space C, and they're all gone. So I can use rm on multiple files at once. Now, if I create these files in this directory, and I move up a directory, I'm now back in temp, and I want to delete the folder tutorial. I want to delete this folder, and I want to delete everything inside of it. If I run this, it says can't remove tutorial as a directory. And I would have to remove everything inside of it. So here's what I can do. There is a command called rmdir that says directory not empty. Here's what I actually do. I never use rmdir. I use rm, but I use the -r option, which is recursive. What this will do is it'll go into that folder and delete everything inside of it. So with that tutorial folder with A, B, and C inside of it are all gone in one shot. So let's put my tutorial folder back. And I created A, B, and C inside tutorial again. What if I wanted to be very careful about what I was removing? I can use rm-i with R for recursive on that directory. Here's what it's going to do. It says descend into directory tutorial. Say yes. Remove regular empty file A. Yes. Remove empty file B? No. Remove file C? Yes. Remove directory tutorial? No, because I still have something in it. So now if I go inside tutorial, all that's left is B. So what the -I does is says, hey, interactive, don't just automatically do it. Ask me for every file. Obviously, you don't want to do this with large directories because you'd be sitting there typing yes all the time. But you can use the -I to make it interactive for yes, I want to delete this. No, I don't want to delete that. Yes, I want to delete that. No, I don't want to look in that folder. Yes, I want to delete that. So RM, remove files and folders. Okay, what if I want to make a copy of this file? I've got this file B. I want to turn it into file E. There is no rename. There is a copy, and there's a move. So move basically ends up being renamed. So copy is CP. So copy B to E. Now I have B and E. So CP for copy, what you want to copy, which was B, our pre-existing one, what you wanted the new copy called, in our case E. You can use other folders too. So copy B to some other folder, let's say Brock P. Notice I'm just given the folder name. What this does is it uses the name of the original file. So now there's a file called B in home Brock P. If I wanted to copy B to home Brock P and call it C, this is what I would do. I would give it a final name on the end, and that will change the name of it. So copy copies things. Notice how I'm combining both relative. This works because I'm in the folder tutorial where B exists, but then I'm using the absolute for the destination, starting from slash, to copy it into a different folder than the one I'm currently in. If I don't specify a folder, it's different. I can also combine it with the dot dot. So dot dot slash, that just copied B to this folder, or the folder one up from the one I'm currently in. So if I CD to that folder now, I'll see B. So I'm going to delete B, go back into tutorial. So what if I don't want to copy? Because copying takes up a lot of space. If it's big data, it'll take a long time to copy it. What if I just want to change the name of it? What if I want to change B to B.final? Because I'm all done with my work and this is the final version. What I can do is, instead of copying it as a new name, which will copy all the data, is I can use move or MV. MV is basically rename. So B to new name, B.final. ls. The original B is gone. Now I just have B.final. Again, you can use, instead of the same directory you're in, you can use slashes and such to refer to different folders to move things around. Remember, starting from slash or using dot dot or moving into folders deeper than the ones you currently have. So that's how you get stuff around. How do I find out how much disk space a folder is using? Everything inside of a folder. So here I'm inside this temp directory. How do I know how much space this uses? Okay, well I can do the ls-l. Oh, wait, this folder, nwchem, it shows us up as 4K. I know it's bigger than that. What I can do is I can use the command du for disk usage, nwchem, and this will tell me how big everything inside of it is. This is generally not that useful to run it by itself. So what I do is I run du -s for summary nwchem. And see, it gives me the final total size of the entire folder. This is in bytes, which most things are bigger than that now. So you can use du -sh. H means human readable. Remember, this also works. nwchem. So it's 196K. So what if I want to find out everything inside temp? I do du -sh dot to refer to the folder I'm currently in, because I'm currently in temp. I run that. The du command is slow because it's going to go to every file and sum up all of them. There's a lot of files in here. So this is very, very slow. So avoid using du unless you have to. But if you need to know how much space something's using, you can definitely use it. Oop, permission denied. Whoops. So here's a little something. DU is running for a long time and I didn't expect it to, or I'm doing something I didn't mean to do. How do I kill it? How do I stop it? Oh, I'm using 3.1 terabytes. Okay. How would I kill that DU while it runs? I would hold Control and press C. That means cancel. You'll see this little caret C pop up. That means I typed Control C. So Control C is the kill. So if you're running something that runs for a long period of time, hit Control C. And that fixes everything for you. That'll kill it off. Sometimes it won't die right away because of what it's doing, but just hit Control C a couple of times and it will be done. Okay, so that's the basic file manipulation commands. So as a quick refresher, we have ls, which lists the files. We have ls-l that lists the files with a lot of details. We have pwd that prints out what directory we're currently in. We have cd, which lets us switch between directories, change directories. We have mkdir, which makes a directory for us that we can then put stuff into. We have rm, which lets us delete files. We have rm minus r, recursive, to delete directories and all the files inside of them. We have move, that lets us rename and move files around. We have du, that lets us find out how much space a directory is in use in a given area. Okay, so what I'm going to go into next is a bunch of tips. So before we go any further, are there any questions? I see one question. What is the command to refresh the terminal? I'm assuming what you mean is how do I make the terminal go clear? So get everything off the screen so that I have less clutter. The way I do it, just because of muscle memory, is Control L. That clears everything else out. But what you can do instead is you can just type the command clear, which clears the terminal out so that all the clutter's gone. If that wasn't what you meant, please put into the chat box with a little bit more information what you're wondering. Other questions before we continue? Okay, so these basic commands let you navigate the file system, copy files, rename files, find out how much space you're using, make folders, move files into those folders, things like that. I showed you tab completion, which lets you avoid having to type out the entire file name. I'm going to show you a couple of other tricks. Okay, I'm going to make a couple of files. That's A, B, B. So I have 4 files, A, B, and BB. What if I wanted to list all the files that started with A? How could I do that? Well, I can type ls, but that lists everything. So what I can do is I can type lsa, but that lists just lsa. I can list lsaa, and that shows just the second file, AA. How do I get A and AA, but not B and BB in the same thing? Well, what I can do is I can use a wildcard. I can use ls A star. Star means A followed by anything. So this shows me A and AA. So if I had a lot of files in this directory, A1, A2, A3, AA1, AA2, AA3. I have a lot of files that start with A, and I want them, not the B's. I can do ls A star, and it shows just those. What if I want just the ones that start with AA. So basically this subset here, I can do ls AA star. See? So the star is extremely handy for doing things, and you can use it for all sorts of stuff. So, and you can put the star anywhere. What if I want to list every file that starts with anything but ends in the number 1? I can do ls star 1. Anything before 1. Oh, the question, what is touch? Touch is just a command that creates an empty file. You pretty much never use it. I'm just using it for a shortcut here. It actually does some other details in that, but for the average scientific user, you don't need to use touch. But in the way I'm using touch here, it just is creating a file that's empty for me. Touch creates a file. Makedir makes a directory. So file holds data, directory holds files. This thing with the star works with directories too. So if I make a directory ASDF and I do ls a star, it includes the directory ASDF as well as all the files in that directory that start with that. So the star can go anywhere, and you can get really fun. What if I want A followed by anything followed by 2? Whoops, I gotta have ls in there though. A followed by anything, which could be nothing, followed by 2. A followed by anything, which in this case is another A, followed by 2. So the star is super handy for globbing, that is grabbing groups of files and looking at only them. And this works for move. What if I want to move those 2 files, A followed by anything, 2, into that directory ASDF? I can do move A star to the destination directory. If I look inside that directory now, there's my 2 files inside that directory. Question, what is the related command is nano or VI? How are they different from touch? Touch creates an empty file. What it really does is it updates what's called the access time on a file, which is just metadata from the last time a file was accessed. Nano and VI are text editors. They're actually for making text. And actually, I'm going to give a tutorial on using Nano at the end of this because it's extremely handy to be able to edit files from the command line directly on the system. So I'll touch on Nano in just a moment here. So the star is extremely handy, and you can use it with ls and move and other things to grab groups of files that match some pattern. The next command is probably one of the most useful in terms of helping you understand what's going on is the man command. Man stands for manual. So the manual for ls, remember ls lists files. If I type man ls, here is the documentation for ls. So ls lists directory contents, ls option file name. Things in square brackets are optional. Notice I've been typing ls by itself and it prints out everything. Or I can give it -l, which is an option, or I can give it, a star 1, which is the file. And so you can just use the up arrows to move up and down. And these are the other options. So you'll notice there's a lot more options than what I used. There's all, there's enable disable colors, there's show the current directory, change the printout format in case I wanted to sort it, use human readable for file sizes. Instead of printing out a big number of bytes, actually say, 1 gig and 14K. But you'll notice -L. Here we go. Use the long listing format, which is the printing out all the details. How did I look for that? So up and down moves between, the different lines. When I hit /, notice down here how it turns to /. Now I can search for what I want. So say I want to find information on a group. I can type group and hit enter, and then it will highlight all the instances of the word group. And I can press the letter N to search between them, to jump. And it says pattern not found here at the end. So man is the manual. When you're curious if a command, how to do something, but you know the command is copy, type man cp, and it will give you the documentation for copy. How do I exit out of this? This is actually a common problem. You hit the letter Q for quit. Just hit Q, and it will leave the manual. So man pwd, print name of current working directory. Doesn't have as many options as ls, but hey, this is still the documentation for pwd. So most of your commands have a manual page for the details you want. Okay, so the last thing I want to cover is using a text editor. There's a lot of text editors, but the one I'm going to cover is called Nano. It's probably the simplest one to get started with. You might be asking a question, do I use Nano myself? Actually, I don't. I use one called VI, but it has a much steeper learning curve. If you're interested in learning VI, there's lots of tutorials online, but if you're curious or just getting going quickly, Nano is what you want to start with. So before I go into that though, are there any questions before I continue? Okay, it doesn't look like there's any questions. If you're still typing your questions, go ahead and type in and we'll be sure to touch on them. Emacs is another text editor that's very popular. Legion, it's going to depend on what system you're on, why man pwd doesn't show anything for you. On Flux, obviously it works where I'm doing my tutorial. Oh, okay. Your Windows command line is completely different. This is not meant to cover Windows. Windows has its own thing. Yeah, I honestly don't know Windows. This is meant to cover Unix-like systems, so Windows is a whole another deal. Okay, so Legion. Okay, if you use PuTTY, which is an SSH client on Windows, so remember when I showed SSH? PuTTY is SSH for Windows. If you SSH to Flux login and then run the command in the PuTTY window after you've SSH to Flux login, the man command will work. If you have more questions about that, please let us know. Rafa, why VI versus Nano versus Emacs? They're all text editors. They all have their strengths and weaknesses. Mostly it's what you know and what you can get help on from those around you. VI is what I learned because the guys I was working with knew VI. But I work with some people who use Emacs. Most of the power users I know do not use Nano. They use VI or Emacs, but Nano is a great place to start. I started with Nano. I started with Nano and another version of Nano called Pico. Actually, Pico was before Nano, but they use the same commands. But they're a basic text editor. So if you want to learn VI or Emacs, definitely go learn that. They're definitely more powerful tools that can do more things, but Nano is the simpler one to start with. So let me go ahead and do the Nano tutorial. So Nano is a text editor. So inside this folder, how can I manipulate the data in these files? If they're regular text, like say a CSV data set, or a source file, like a Fortran source file, or a MATLAB M file, or an R batch script, or a PBS batch script, they're just plain text files. So how can I edit them? Well, a lot of people, they would use a file transfer client to move the file to their local machine where they'd use Notepad or TextEdit or TextWrangler to modify it, save it, and then re-upload it to the remote machine. I don't like doing that because there's a lot of extra steps. I like editing directly in the terminal. And the way I do that is with a text editor. And so the way I do that, the command for nano is just nano. And then I give it the file name I want to open. So here I give it A2. A2 has nothing inside of it, but here we are inside of nano. So this is just a text editor. I have the options at the bottom. It says how many lines it was. This is an empty file, so it has 0 lines. And my cursor's right here, so I can just start typing, this is my data. There are many like it, but this one is mine. Okay, so this is my text file. It could be, like I said, source or anything else. And I can just keep typing stuff in here. Now, how do I save it? You actually do what's called write out. So you see this little caret thing here? This actually means control, and this is the letter O. So to save this, I would hold control and press O. It's going to say file name to write to. It's going to remember the file name I opened originally, but say I ran nano without a file name. I wouldn't have a file name because I'm making a new one. Or I wanted to change this to a different name, I would type in here what I want. But I just want to write over A2 with the new contents. So I just hit enter and see it said wrote 3 lines. So now if I exit with Control X down here, I exit nano and I'm back here. There's my A2. If I type ls-l, notice A2 has some size now. And if I reopen A2 in nano, here's my text data inside of it. So nano is a very simple text editor, but you can use it for editing your source files, your make files, simple bits of data, as long as they're plain text. This will not edit an Excel file, right, or a binary database. But if it's plain text, you can definitely read it in with these and edit it. So this lets you edit everything on the cluster or on the remote system and not have to transfer files back and forth. So any questions about nano? Okay, so that's everything I had planned to cover. There is a second section, which is the same time next week, so Thursday at 1:30, same place. And we're going to continue on with a bunch of other commands. We're going to show you how to do more advanced things. We're going to show you how to look for subsets of data inside files. We're going to show you how to sort data from files, compare 2 different files, and to chain these little commands together that sort, find unique entries, and look for unique strings of text, to combine them together to basically be able to do small data manipulation directly on a machine without having to use any fancy, heavyweight, high-powered tools that either cost money or have to be installed, because any command line Linux or Mac system will already have them. So again, this is recorded and will be on our YouTube site. If you have questions, you can get a hold of us at hpc-support@umich.edu. If you're curious about learning to use the cluster specifically, we'll be covering more information in the future, but there's also information on our website, which is cac.engine.umich.edu. Again, my name is Brock Palin, and I'm one of the admins at Kane High Performance Computing. We are known as the operators of Flux and Nix, which is a traditional high-performance computing platform. I am also the campus champion for the Exceed project, which is a National Science Foundation. And we're generally here to help anybody with any type of computationally based research or classroom work on campus that involves computing, Unix environments, and just getting work done in the most efficient way possible. So if you have any questions, go ahead. I'll hang around for a bit, and Matt's here also. Please put any questions you have into the text box, and we'll make sure that we cover that. Rafa, do you mean a make file? Or, oh, you want to type ls and have it do ls-a every time. Okay, you can do that using what's called an alias. So what that is there's a command called alias, which lets you create fake commands. So I'm going to make the alias ls be ls-la. And so now if I type ls, it means ls-la. So you can make aliases of any name. So a lot of people unalias ls, so I'm back to normal ls. A lot of people make the alias, a very common alias to see is ll, which is exactly that. It's ls minus la. And so then when they type ll, it does that, but I still can use normal ls. So aliases are handy. You can combine stuff together to do different things. You can also just make your own command as a shell script. So if I make a script, so nano, and I put in here and I run bin bash, which is the shell. This is what I'm running in here is actually something called bin bash, and I can run script 1. Script 1 just runs the shell commands inside of it. So I just pasted a bunch of commands that I just taught you guys into script 1, and I can run bash that command, and it will run all the commands inside of it. I have a MATLAB file. When I open it using Nano, it does not show up correctly. Does it have a bunch of... Okay. Is it a MATLAB.mat file, or is it a .m file? If it's a .mat file, that's binary data, and you won't be able to read it in Nano. If it's a .m file and it's plain text, if it looks like it has the right text but the end is screwed up, that's because if you edited that file in Windows, Windows uses a different new line character, and you can fix it by using the command DOS to Unix, myfile.m, and that will fix the weird lines. If you're not sure what type of file it is, use the command file. If you use the command file, it'll kind of try to figure out what it is. And so if it says that is ASCII text, like A2 here is, because I put some stuff inside of it, or file script 1, it says it's a shell script. If it says it's binary data, it's probably a MAT file, and you won't be able to use Nano to look at it. You'll have to open it up in MATLAB or some other tool that understands MAT to interpret the data correctly. If you're having trouble with some of the stuff you're doing, Legion, just send an email to us at hpc-support, and we'll make sure you get specific help to what you're trying to do. Other questions? Chai, you wanted to know if we were going to learn about the find command. I don't know if that was on my other list, but I'll make sure that it's added so that I make sure that I cover that next time, because that is very powerful, and it's very powerful combined with some of the other commands. So I'll make sure that we do cover that next time. Amber, you want to know about using Nix specifically? Send an email to hpc-support about what you want to be able to do and what your unique name is, so we can verify what you have access to. So we can talk about specifics, because Nix is a little interesting and specific. Now, there are sessions what's called HPC 101 or PBS Basics and stuff like that. Most of what applies there applies to Nix with a little bit of tweaking. So we can talk to you about specifics for what you're trying to do. But we can talk about Nix. Nix and Flux are really the same machine. They're really just how the resources are allocated. Guest 4, you want to know, are aliases saved once you exit Flux? No, they're not. There's something called your environment that is not saved, and so you have to create these RC files that are ready in every time you start. That's well beyond what we're doing here, but look up something called bash RC or bash profile. Type that into Google and you'll find all sorts of information on how to do it, because it's a very common thing. I actually create aliases using modules, but modules is something specific that we've installed on the HPC clusters at Kane. that don't necessarily exist everywhere. So the bash RC and the bash profile is a traditional way that will work everywhere. Other questions? Does everyone have his or her own environment? Yes. So, and actually not only that, every login has their own environment. So there's a default environment we give you when you log in. And then you can change it using modules or bash RC or running commands like export or alias that manipulate your environment. Those changes you make only live in that login. So like this shell I have open here, and I ran that alias command and made the LL alias. If I log in to Flux again, LL won't work in that shell unless I add it to my bash RC. But then once I add it to my bash RC, only I see it every time I log in. My lab mate does not. They need to add it. This is actually really powerful because if you're using like our cluster and you want to submit batch jobs, that is long-running computational work that the cluster chews on, and your application you're using, you have two different applications. If those applications require different environments, it would be terrible if you could only run one of them at a time. What is actually handy is you can log into the cluster, set the environment for application A, submit those jobs, and the environment goes with those jobs when you submit them. So the environment for those jobs when they run is frozen now. You can then change your environment again and submit the jobs for application B, and the environment for those jobs are frozen. So now those two sets of jobs can run simultaneously on the cluster and work successfully, each running in their own environment. So you can actually create many thousands instances of an environment. Most of the time you only have slight permutations of the default environment you start with. Other questions? Okay, well, I think we're going to wrap up here. I'm going to shut down. Again, we will continue on covering more details same time next week, so Thursday at 1:30, same place, same format, and this will be recorded and posted to our YouTube YouTube website, as well as on the webinar series section of our website. Also, if there's specific topics you want to make sure that are covered, or you have questions in general, be sure to send them to us at hpc-support@umich.edu, so we make sure that the needs of what things would be helpful for you are actually being provided. The YouTube link, yes, I can get that to you. The YouTube link is there, and the generic support address for high performance computing is hpc-support. Even if you don't use our existing systems, we can educate you on what's available, or point you to somebody who can help you if our systems do not meet the needs of what you were trying to do. So always be more willing to ask questions of us, so that we can help you than not. Okay, thanks a lot.